We will be learning today about the resistance and two different types of the combination of resistance and how to find out their equivalent resistance. Before we understand the combination of resistance, first we should know what is a resistance. Basically, you can see that I have shown the flow of the current with the help of a blue arrow. This is showing that the current is flowing from the left hand side towards the right hand side. But the hand is obstructing the path of the electrons. It is not allowing the electrons to flow freely. This is called as the resistance, which is the measure of the difficulty which occurs on the flow of the electrons. You can see in the second figure that the first diagram we have made is providing the complete flow of the electrons in a smooth manner. So the conductor is allowing the electrons to flow easily. But whereas in the second, as we have increased the resistance, we have squeezed the path of the flow of the current, and so it is difficult for the currents to flow properly, and that is why, because of the more resistance provided, the electrons cannot move easily, and so the amount of the current which is flowing also decreases. Basically, the resistance is being calculated by the formula that we have mentioned here, and it is dependent on two factors, that is the length as well as the area. As I'm going to increase the length, the obstruction also increases, and so we can say that it is directly proportional to the length. Means as I'm increasing the length, the resistance is also increasing. Whereas if I'm going to increase the area, I'll be providing more space to the flow of the electrons, thereby the obstruction becomes less, and that is why the resistance also decreases, and so the electrons can easily flow by increasing the amount of an area. The resistance is dependent on the resistivity in a manner because the resistivity of a substance is a constant value. It never changes. If of any substance, it remains the same. So we can't say that resistance is actually proportional to the resistivity, because the resistivity of any substance will remain the same only. The resistance do vary with the temperature, because as we are increasing the temperature, the resistivity of that particular material also increases, and so because of the change in the resistivity, the resistance also varies. So at a constant temperature, the resistance is again a constant value if the length and the area both are not changed. But if the length and the area is altered, then there will be a difference in the amount of the resistance. Now let us understand about the combination. We are having two combination. One is a series combination and second is a parallel one. The series combination, we consider it as a series combination if I'm going to start drawing my circuit and I am starting off from R1, that is my first resistance. Then this R value, the R1, I'm not going to uphold my pen at any moment. I have to continue drawing the figure, and I will be able to continue and complete my circuit without even withdrawing my pen from the figure. Only then it will be called as a series combination. Means all the three resistance or 4 or 5 or whatever the number of the resistances, it should be in a straight line with each other. It should be in a series, means the current is flowing from R1 to R2 to R3 to n number of R's which is there in a combination. Such kind of the combination is called as a series combination. Whereas in case of the parallel combination, as you can just see in the figure, if I'm going to start and allow the current to flow through an R1, I need to withdraw my pen from there, and then only I can allow the current to flow into the R2. Means I cannot draw this figure without withdrawing my pen from the paper. So such kind of the combinations are the parallel one, where I know that the current will be, some of the amount of the current will be flowing in R1, then some in R2, then some in R3. Right, so here in this combination, the pen needs to be withdrawn. That is the easy way of remembering that what is a parallel combination and what is a series one. That in series case, we are not withdrawing the pen from the paper, whereas in case of the parallel one, if I need to draw the figure, I need to withdraw my pen from the paper, only then I will be able to draw this figure. That is the parallel combination. We will be learning about their characters in the upcoming slide. First we move on to the series combination. You can just see, again we have shown it in the figure, how the series combination is connected, and in the actual manner also how the series circuit is, where the battery with the copper wire is there and both the bulbs are in series combination, means side by side. right? If I'm going to again draw it with with the help of my pen, I need not to withdraw my pen from the paper. Only then I will be able to draw the series combination. So if different resistance, they are joined with each other such that there is only one path that is provided to the flow of the electrons or the flow of the electric current, then such kind of the combination is called as the series combination. You need to know that the current which is flowing through such kind of the resistors, they are constant. Means if I is the amount of the current which is flowing through R1, the I will be flowing through R2 only, and the I will be flowing through R3 only, right? Because the entire amount of the current will be flowing in the first resistor, second resistor and third resistance. So the value of I is constant in all the three resistors. But the potential difference, that depends upon the value of the resistance. It varies. Means with in case of R1 we need to show the potential difference with the value of V1. In case of R2 we need to show the value of the potential difference with V2, and R3 we need to show it with V3. So my total V will be equal to V1, V2, V3, means my V will keep on changing with respect to the R. The equivalent resistance is equal to the sum of the individual resistance. It's a simple sum that we calculate in case of the maths. We will be learning how to calculate the equivalent resistance in the next slide. So let's derive how to find out the equivalent resistance in a series combination. Here we have taken the three resistors R1, R2 and R3 which are connected in series, and here the current is flowing from the cell to R1, then from R1 to R2, from R2 to R3, and finally it goes back into the cell. So by following the Ohm's law, the potential difference is equals to IR, that is V is equals to IR. And I have said in the previous slide that in case of the series combination, the current remains constant throughout the circuit, whereas the potential difference varies across the resistors depending upon the value of the resistors. So the R1 will be having the potential difference as V1, and we will be calculating it by V1 is equals to IR1, as my I is constant. Then the potential difference across R2 will be V2, and that is equals to IR2. Similarly for R3, my potential difference will be V3 and it's equals to IR3. You can see in all the three, V1, V2 and V3, my R is same because the R remains same throughout the circuit. Thus, when we're going to find out the total potential, that total potential will be equal to the sum of all the potentials we are having in a circuit. So my total potential V is equals to V1 plus V2 and plus V3. If I'm going to put up the values of V1, V2 and V3 in terms of I and R, so it becomes V1 is equals to IR1 as we have seen above. So on place of V1 I have written IR1, on place of V2 I have written IR2, and on place of V3 I have written IR3. So my complete V is equals to now IR1 plus IR2 plus IR3. Because I is same in all the three, so I'm just bringing it out as a common factor, and then I in a bracket I have written R1 plus R2 plus R3. So thus in the series combination, this R1, R2 and R3 is equals to the total resistance, and so we find it out the total resistance as by simple adding up all the values of the different resistors. So here, in order to find out the maximum resistance which is flowing, then it has to be in the series. Means the equivalent resistance, the value of the equivalent resistance will always be greater than the value of any of the resistance, because it is the simple sum of the combination. So here we have taken three resistors, so we have taken out as R1 plus R2 plus R3. But for n number of the resistors which are connected in the series, this R1, R2, R3 goes to Rn. Means we simply need to keep on adding up the values to find out the total resistance if my resistors are connected in series. Next type of the combination comes as a parallel combination. In this combination, as in terms of an arbitrary Now let's derive how to find out the equivalent resistance if the resistors are connected in parallel combination. You can see in the figure that R1, R2 and R3, all the three resistors are connected in parallel combination. We know that in a parallel combination, the potential difference remains constant throughout the circuit and across the different resistors, whereas the current which is flowing splits into different parts and which in totality combines and form the total current which is flowing in a circuit. So when the current is moving from the positive side and entering into the three split ends, then the current will be split into I1, I2 and I3 and going into different resistors. I1 will be going in R1, I2 will be going in R2 and I3 will be going in R3. And after coming out from all, it will all be combining together and forming the complete and the total current which is flowing in a circuit. So the total current I is equals to I1, I2 and I3. If we separately consider that the current flowing to R1, that I1 will be equals to V upon R1 because V remain constant, so we have not put any number coefficient in front of it. So V upon R1 is the current flowing in the first resistor. V upon R2 is the current flowing in the second resistor and V upon R3 is the current flowing in the third resistor. Now as we know that the total current is equals to I1, I2 and I3. So if I'm going to put up the values of I1, I2 and I3, I will be getting V upon R1 in case of in place of I1. In place of I2, I will keep V upon R2. In place of I3, I'm going to keep V upon R3. So taking V as a constant and common. So in the bracket, I have written 1 upon R1 plus 1 upon R2 plus 1 upon R3, which is actually equal to the total and equivalent resistance of the entire circuit. So whenever the resistors are connected in parallel combination, so the equivalent resistance is calculated by 1 upon R1 plus 1 upon R2 plus 1 upon R3, that goes to 1 upon Rn if we are having more than 3 combinations or as many combinations in parallel one. So in parallel combination, the total resistance is determined by adding the reciprocal of the resistance of each individual resistors. Now let's practice how to find out the equivalent resistance of the different combinations. In the first example, you can see that we are having four resistors R1, R2, R3 and R4, and they are connected both in series and parallel combination. Now you can observe that R1, R2 and R4, all the three are in series, but R2 and R3 are in parallel combination. So first we will be finding out the value of the equivalent resistance of this parallel combination by putting up the formula 1 upon R2 plus 1 upon R3. When we will find out the equivalent resistor, consider it as R only. Now my R1, R and R4, all the three have come in series combination. So I simply have to add up all the three values and I will be able to get the equivalent resistance of the first example. Moving on to the second example, you can see when the circuit is beginning it up, then the R1 and R2, these both are in series combination, whereas R3 and R4 are in series combination. Means if I'm going to add the value of R1 and R2, means 4 plus 4, that will come out to be 8. The value of R3 and R4 means 4 plus 4, that will also come out to be 8. Now consider the series combination of R1 R2 as R12, and so the value is 8. In the third R3 and R4, by summing up their values, consider it as R34, and that R34 will also have the value of 8. Now both R12 and R34 are now in parallel combination. Means by putting up the formula 1 upon R12 plus 1 upon R34, I will be able to calculate the equivalent resistance. This is how in different combination you just need to observe that what all are in series and what all are in parallel, and accordingly you need to calculate it. In such kind of the numericals, three things can be asked. One is your resistance, the equivalent resistance of the entire circuit. The second thing is to find out the potential difference, and the third thing is to find out the current. So you should know what you need to keep in mind, that in series combination the current remains same, but the potential difference across the different resistors keeps on changing, which in totality is equal to the total potential difference across the circuit. Whereas in parallel combination, the current is not constant, it keeps on changing, it splits into different and goes into different resistors, whereas the potential difference across each resistor remains constant. So by keeping all these important points in your mind, you will be able to solve the numericals.